Hello, I hope you are doing well. In this video we are going to talk about simulation of multi-phase systems. The first point is when you start the COMSOL Multiphysics software, you will face this window. That means that you can either select Model Wizard or Blank Model. If you select Model Wizard, it means that the software helps you to select mandatory preferences for your simulation. For example, the dimension of your system, the physics that you want to simulate your model with, and the study mode of your system. It can be either time dependent or stationary, or even it can be frequency domain studies that is for electrical purposes. For selection of space dimension, as you see, you can select 0 dimension, 1D dimension, 1D axisymmetry, 2D axisymmetry, and 3D. It depends on your geometry, on your system, and on your assumptions. If you want to simulate your model in 2D, it means that in one direction, the differences between your independent variable is ignorable. On the other hand, if you select 2D axisymmetric, you will decrease the size of data that you are producing, that you are solving your problem with, since your geometry will be cut to 2 different parts, and just one part will be solved, and the results will be used for both sides. And the number of nodes in 2D axisymmetry and the 2D in 2D axisymmetry is half of 2D, so the computational cost of 2D axisymmetry is lower than 2D. On the other hand, when you increase your simulation to 3D, the computational cost of your system will increase, but on the other hand, it should be considered that your equations will be more unstable. It's not about just time, it's about instability of equations. That means you cannot reach a stable equation, a stable results, and conversion of your calculations, since the basic of this software is based on finite element method, or FEM method, that is kind of numerical technique for solve multiphysics systems. For example, I select 2D. In the second step, you select the physics that you want to simulate. There is different interfaces in COMSOL Multiphysics. Each of them is for a specific purpose. So since we want to simulate multi-phase systems, we should go to fluid flow part and in multi-phase flow. Mostly for liquid and liquid gas, that 2 phases are inimmersible, we select either level set or phase field. So if I select laminar flow or level set, in the next section, you should select the kind of study that you want to investigate your system. Since the behavior of multi-phase system is mostly time dependent, you need to select time dependent with phase initialization. Therefore, I click on Done. Okay, it is a COMSOL Multiphysics window. So the first step in any simulation is defining your geometry. So I changed the length unit of the geometry to centimeter, and then I right click on geometry and I select rectangle. The width, I select width with 10 centimeter and the height with 2 centimeter. It would be a rectangle like this, and I want to put a port like this here, and then because of this I just duplicate this and I decrease the width to 2 centimeter and the height is half centimeter. It would be something like that. I rotate it 90 degree and I move that to centimeter and 4 centimeter here, or 3. So I have a kind of a channel and a lateral inlet. I made my geometry union by using Boolean partition, by right click on geometry, going to Boolean partition and make them union. I keep interior boundaries because I want to define different phases domain. If I remove this, I don't have access to these boundaries. Therefore, I just select it because I need it. I right click on materials. So I select engine oil and air as the 2 fluids that I want to investigate in my system. So I don't need to define the domains that any fluid is persisting, so therefore I just define them in material section. In another part I go through the laminar flow simulation, laminar flow module. Here Navier-Stokes equations. This equation will be solved for two different fluids. I have 2 inlet. The first inlet is this, and I define the velocity 0.1, and the second inlet is this, and I define it 0.2. I have one outlet here that the pressure is 0. That means it will release in the environment, and the equations is this, the equation for this boundary condition, and for each boundary condition you can see the exact equation. It is walls, that means no slip boundary condition will be considered that velocity is 0. On this walls it is initial value, that is there is no velocity, and it is the properties of your system that is coupled with the module because they will change with time. Okay, it's the setting of laminar flow. We go through the level set. We have one inlet here that is fluid 1, and we have one inlet here that is fluid 2, and I have here an outlet. And also this is the equations for level set. You can see the meaning of equations in any part. The phi is the location of interface between 2 phases, and it is a partial equation that they will be solved for finding the interface between 2 phases by time. So I have inlet of 2 different fluids, fluid 1 and fluid 2, and an outlet. And then I come to wetted walls, and I select the walls that they will be in contact with 2 fluids. And in 2-phase flow model, I select which fluid is the first fluid. I select the oil as a first, and water as a second. Okay, I selected air here. Let me add water, and in the next step we will change it to the Okay, here the first fluid is oil and the second fluid is water, and just to this fluid, oil and water will be considered in our calculations since we didn't choose air, so there is no application of this material in our simulation, so it's okay. So I mesh it based on default of COMSOL, and I go through the phase initialization. I can change the start time, the time step, and last time. I change the last time to 10 seconds, and I use the plot here to, since I want to, I can decrease it because I want to be sure that it's running. That's it. I just activate this because I want to see the results during the run, and also if I change it from time stored in output to time step taken by solver, I will see the results in any time rather than just in a specific time steps. And by clicking on compute, okay, when your simulation is running, you can track the progress of your work. For example, if you click on progress, you can see how much percent of your file proceed, and also if your simulation is time dependent, you can see in which time step you are. So it is 0 now, and it will start to work. Since we defined we activated this plot, and it will, you see, it will be changed, but it is the velocity magnitude, and you can change it to any other variables that you want to track during time. The red means that there is more velocity, the velocity is higher, and the blue is the velocity is lower. If you see there is lower velocity near walls, it's because of no slip boundary condition near walls. And you see that if the velocity, the much more fluid add to the main channel, the velocity increase since the flow rate increase. So it is the velocity, it is the pressure, and it is the volume fraction of the fluid. So if I want to increase the time, I can just change it to volume fraction of fluid, and then I can increase this to 5 seconds. You must be very careful regarding your dimensions. If you want to simulate a big system, it would be a little bit challenging, since the equations will be highly unstable when you are working with those stuff. So you see that the fluid that is coming inside, the gray line is the exact boundary between two phases, and these colors is due to the computational considerations that it is a specific thickness between two phases. So you can see the progress of your second, first fluid. That is the second fluid, that is water. So you see your model is running here, and you can track the specific volume fraction of any fluid, two fluids that you are working with. We can stop it, and we can go through the another settings. I just cancel it. So the next model that I want to simulate is I want to change the fluid. Of my first fluid was oil and my second fluid was water. Therefore I want to just change one of them to air. So let's check. I have one inlet here, and I have one inlet here. It is fluid 1, and I want to just change this fluid, that is fluid 2. Therefore I come here, so here I have oil, and here I change it to air. So the air will be added to the system rather than the water. So here would be air, and here would be oil. I compute it. There is a point when you are working with gas fluid systems rather than liquid systems. The system would be a little bit complicated, since the interaction between two phases is not so much, and on the other hand the air, the gas, will be affected with the first fluid that can be either oil or water. And since because of this, the equations sometimes are more unstable. But generally for this simulation I think it's okay, and there is no problem. Okay, as you see, there is no problem for this run also, and you can investigate your system either with liquid or liquid gas situation. I cancel it. So another point that is that maybe you want to consider the gravity in your system. You can just activate this checkbox here, and your gravity will be added to your system. Since if you consider the Navier-Stokes equation, you can see a rho g term, that is gravity that added to your system. If I remove that, you don't have rho g here anymore. But I activate that. I want to investigate the effect of the gravity on your simulation. Therefore, if I activate this, and if I want to have water here, I want to have oil here and water here. Therefore, I have the first fluid that I want to be oil, and the second one is water. So I select the first one is oil, sorry, and the second one water. So just it's when I have gravity force. The point is, when your model is running, there is an error, and its iteration number, it should reach to a small value since your equations are converged, and yes, it starts to run. Actually, when you add external force such as I don't know, gravity force and any other forces such as I don't know, even some people they want to consider effect of magnetic fields and electrical fields and behavior of bubbles in the microchannels. So therefore, it would be a little bit more not unstable. When I am saying unstable, it's not meaning that you cannot solve them. That would be a little bit more challenging than when you don't have that force. So adding force, adding anything to the equations increase the computational cost. Sometimes not so much. Sometimes it can affect your simulation highly, and you cannot reach to any other result that you want since you just select a wrong, you added wrong term on your model or on your equation. So you see everything is okay, and it's running also. The point is it's just two materials that we selected from the software library. If you want to change the property of the materials, you can, as you see, there are a function of temperature, but you can just put numbers in your number here. If, for example, I don't know, if you come here and you see that your density is a function of temperature, it's a function that defined in COMSOL Multiphysics library. I define it just manually like this, kilogram per cubic meter. So bracket close. So it's okay. It should be, as you see, it should be black. If I remove this, it would be kind of orange. It means there is something wrong with your unit. If you keep your mouse here, you see the error that is unknown unit. If I just put it like this, and if I remove this, it would be red. It means that there is something wrong with my number, not about a minor stuff such as unit. It's wrong definition, so I need to close it. Therefore, you see, you can change anything that you want for your properties. You can add new materials, a blank material, and you can just add your property here. But here you can just change it. If you change the property for a new fluid, and you can change the name here, so it would be another fluid. It doesn't matter. So it's about how you can simulate two-phase flow in the systems. Okay.